Hello, everyone. Good morning, good evening. Welcome back. Welcome to Cloud and DevOps Batch 58. So before I start the session, I just want to make sure I would like to talk today on the networking concept, not related to Kubernetes, because I could see quite limited audience today. So since since Kubernetes is a very important concept, so we talk about auto scaling and all these aspects. But as I see the limited audience today, I just want to touch base on a different topic. However, we have to cover this after this, but I just want to take an input. Okay. Uh, okay. Let's start with networking in AWS. Okay. Not just networking in AWS in general. Okay. So how, okay, how one device, okay, how one networking device can talk to other networking device. So if you and me have to talk to each other or express whatever I intend to say, we both should know a common language, right? And I should have an identity. Likewise, in the space of network is nothing but a bunch of devices that can talk to each other, okay, that are connected over a wire. Let's assume they are in a network, okay? And wire is a acronym to coin the term that they are connected to each other, okay? And if one device wants to talk to each other component, each and every device that we use will have a address, okay? For example, if this device wants to talk to other device, if the device wants to talk to the other device, okay, both of them should have an IP address. And the IP address will be 100.200.1. Okay, this is how an IP address looks like. And this IP address is referred as a IPv4, IPv4. Okay. Since, and this is how an IP address looks like. And if you talk about this IP address, it has 4 values. Okay, and first one is octet 1, and second one is octet 2, and third one is octet 3, and fourth one is octet 4. Okay, the reason why I say octet is, I'll tell you, and the first value, second value, third value, fourth value can be in the range of 0 to 255. Let's use a different colors. Okay, so if you take this, the reason why each and every IP address can be in the range of 0 to 255 is because we call them as an octet. Okay, so what do you mean by octet? So computer understands only 2 values. Okay, so what are the 2 values that computer can understand? 1 or 0. Okay, so whatever you give to the computer or any networking device, it converts the values to the binary. So 1 or 0. So based on that only it can understand. You say Manoj, it converts to ones and zeros. So you take Shailaja, it converts to ones and zeros. You take Harish, it converts to ones and zeros. And then it is going to convert it accordingly. Okay, so for example, each and every entity is referred as an octet. Okay, so what we can do is you take this, okay, and here, six, 7, 8. Okay, this is referred as an octet. And this can have 0 or 1. Okay, and this can have 0 or 1, 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 this can have 0 or 1. This one can have 0 or 1, and this one can have 0 or 1. That's the reason we call it as an octet, because there are 8 values. Octet. Okay, so octet is nothing but 8. Now, since each and every value, okay, so for example here, this is 1, 2, field number 2, 3, 4, but computer always starts with 0, right? 0, 1, 2, 3, 4, 5, 6, 7. Okay, so since each and every value can be either 0 or 1, so you take that as a 2 values. 2 to the power of 0, which is nothing but anything to the power of 0 is 1, 2 to the power of 1, 2 to the power of 2, okay, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, and 2 to the power of 7. And what are the values of it? 2 to the power of 1, 0 is 1, and 2 to the power of 1 is 2, and 2 to the power of 2 is 4, and 2 to the power of 3 is 2 to 4, 4 to 8, and 4 to 8, 16, 16 and 32, plus 64, plus 128. Okay, if you take this 1, 2, 3, 4, and 1, 2, 3, 4, you would get 255. 56. And that's the reason, okay, the range of the IP is 0 to 255, which gives you 256 value. So if you take one octet can offer 256 IP address, what can be the total number of IP addresses? Okay, since these are 4 octets, we represent them as IPv4. So 256 in first octet into 256 into second octet into 256 into third octet into 256 into fourth octet. So what will be the value of it? Calculator. 256 into 256 into 256 into 256. If you take this 429 crores, okay, and 49 lakhs and 67,296, this is the value, okay. And whatever the IP address that was assigned to me cannot be assigned to you. And whatever the IP address that is assigned to me cannot be assigned to someone. That means there can be a maximum of 429 crores. Just take approximately 430 crores. Okay, just for the sake of it. Okay. All right. That means the maximum number of IP addresses that can be formed are 430 crores. Okay. But what is the world population? What is our world population? As of 2024, the world's population is 8.2 billion people. That means 820 crores of people. Even if you give one IP address per person, when I say one IP address per person, assuming that each and every person is using one cell phone or one computer. Okay, but we are just short of 50% only IP addresses are available out of the available population. Okay, but how about companies like Google, Facebook, Netflix, Apple, okay, Google Cloud, Amazon Cloud? They use millions of servers, right? So how can you handle it? Okay, what would be the number of servers in Google's data center? They don't say, I know that. Okay, they are saying Google has not disclosed the exact number of servers in its data center, but estimated is between 900,000 and 2.5 million. That means anywhere in between 10 lakhs to 25 lakh servers. Okay, if you talk about what do you call AWS data centers, even they would be the same 50,000 to 80,000 servers. Okay, so AWS is quite huge. Okay, they are saying they have 100 below less than 100,000 servers, but you talk about Google, okay, they have almost 1 to 2.5 million. No one is close to it. Okay, how many number of servers in Apple data sets? It will be quite less for Apple because they are not into the business of what Google is went into. It says 100,000. Okay, how many number of servers are there in Netflix data center? Again, Netflix operates at a cloud model, so they have 18,000 servers, but it is quite less when compared to Google. So if you take all these things, you cannot accommodate. Okay, as I mentioned, if I want to talk to you and you want to talk to me, we should know each other's address. Okay, so if you assume this, we would have ran out of the IP addresses way long back. Agree? You got the problem statement? Guys, agree or not? Okay, so that's when the concept of public and private IP address came into picture. Okay, so who can use what is the purpose of it? Okay, all these things came up. Let's talk about it. How this shortage of IP addresses was resolved. Okay, let's talk about it. Public IP address versus private IP address. Okay, so public IP versus private IP. Okay, public IP address versus private IP address. So public IP address versus
Manoj, we cannot hear you.
Can you hear me now?
Hello? Yeah, now it's
How
clear.
long you are not able to hear me?
Only this much public IP address.
Okay, all right. So public IP addresses are globally unique. Okay, that means if there is a public IP address assigned to you, it's the same for me, and it cannot be the same for anyone. Okay, it cannot be the same for anyone. Okay, and they are not free, and they are maintained by the internet service providers, so they will offer you. And next is private IP address. Okay, they are not globally unique. Okay, if I'm having a private IP address in my company, you can also have the same IP address in your company. It really doesn't matter, but unique within the network. Okay, they are free to use. Okay, so who offers it? Intranet offers. Internet is nothing but your own network. All right, so this is what it is. Now, since this network is the core of everything, okay, there are some initial principles that are laid out saying that this particular range should be used by airlines. This particular range should be used by big companies. This particular range of IP address needs to be used by this particular sort of network or segment of the companies. Okay, since network is very, very important, there are some rules that are already being laid. Okay, so how IP addresses usage is being classified. Okay, so IP addresses are classified based on the industrial use by using something called as a classes in IP. Okay, so let me take a look at this. IP classes. Public. Yeah, let's take this. Based on the industrial use, we use it. Okay, so typically if you're talking about the IP public address, okay, so if you see any IP address with the range of, okay, if the first octet, okay, I'm only mean first octet, that means if the first number in the IP address starts in the range of 1 to 126, this is referred as class A. And if it is in the range of 128 to 191, it is class B. You might think, where is 127? 127 is your local IP address. If you don't have an IP, okay, so if you want to connect to yourself, okay, initially, I already told you, right? If you want to get an IP or if you want to talk to some communication device, you should have an IP address. But who assigns IP address to your device? So for that, you need to connect to someone which is called as a DHCP server that is going to offer you. During that mechanism, you use loopback IP. That's where 127 is referred as a local IP. And class C, whenever you see any address in the range of 192 to 223, it's called as a class C. And class D and class C. So class E is majorly used for future purposes, okay, 240 to 255, and that's the reason you don't see anything in the range of this. And multicast is mostly used in the broadcasting, radio, airlines, and this kind of network, okay. If you're talking about private IP address, it's okay, yeah, this is the best diagram I can see. Okay, all right. And if you see this class A, class B, class C, class D, and class E, this is the public IP address range, which we already discussed this, but private IP, they are mainly classified into three networks, class A, class B, and class C. Okay, you can either use class A or class B. Class C is used only for smaller networks, like just like your Wi-Fi network or internet cafe network. And if you see all the devices that are connected at your home, or if any devices that are connected on your cell phone that are connected to the Wi-Fi, will be in the range of 192 series only. Okay, if you join any company like Google, Facebook, IBM, all these guys, they form their own network, right? And that will be either 10 series or 172 series. 10 and 172 series are very, very big network. And you know, if you want to start any product or any company, what is the first thing that you do? Anyone? Anyone? If you want to start any company, what is the first thing that we do? If you want to build any product, okay? The first thing that we would do is, okay, we need to build our network. And this is referred as a private network or intranet. Okay, so I think you are already aware of what is internet versus intranet. Internet is a public network. intranet is a private network. Okay, so because you need to build your own perimeter, that means it's very simple. If you are accessing your HRMS portal or salary portal, that is accessible only when you enter into the company. But when you're accessing this application anywhere from outside your network, just like your leaves portal within your company works only when you enter into the company. But if the same application, if you attempt to use from outside the company, it will not work, because these applications are designed to be accessible only from the intranet. Okay, so intranet is a private network. Okay, internet is a public network. Any questions on this, anyone? Harish or Arun? Harish, Arun?
No, Manoj.
Any questions? You understood what I'm trying to convey? Let me take a pause to take up any questions. Let me take a pause. Any questions, anyone? Any questions? Feel free to ask. Can someone confirm me? Am I audible?
Yes, Manoj. Right there.
Okay, all right. So whenever we form any company, or whenever you think about any product or any startup or anything, the very first thing that we need to do is building our own network. Okay, and whenever we will to build any network, the first question that should come to mind is, what is the size of the network? Okay, that means, for example, if you have 100 servers and 300 employees, minimum the expectation is you need to have 400 IP addresses, keeping the future capacity, future growth in mind. We build the network 4 times the size. You need 400 IP addresses, we build 4 times the network or 2 times the network as per the company's growth and visibility. So you need to understand what is the size of the network. When you say size of the network, how many IP addresses that it's going to offer. Okay, and you don't just build one network. Okay, we classify. Okay, we further break the single network to multiple pieces called as subnetworks. It's also shortly called as subnets. Okay, this is to make sure rather than you just create one big network and apply rules across the board, rather what we do is, for example, I'll give you one classic example. If you assume this as your office, let's assume this is the first floor, the data center. Okay. This first floor, second floor, and third floor, this is reception. Okay, let's assume this is a reception area. And this is project area. And this is a data center. Okay, so now what I want to do is, okay, now what I want to do is, what I wish to do is, okay, now what I wish to do is, okay, what I wish to do here is, I want my big network. So for example, typically this is a public network. Okay, here anyone can access, public access. So people who enter into this reception can still access the public network. So once you enter into the project ODC, offshore data center, private network, okay, for example, no access to internet. No access to internet, let's say. And this one, limited access to internet data center, because patching and all these things will be there, right? Limited access to internet. Okay, how can we make sure, though this is a big network, this is like a corp net, okay, assuming it is a corporate network. Now you built a very big network, okay, and how do you define the size of the network? Okay, what represents the size of the network? Okay, the size of the network is represented by CIDR. Okay, classless IP domain rotation. For example, if you say 10.20.30.0/16, okay, this means first octet is already filled and second octet is already filled. /16 means how many bits are already occupied. So first 8 octets and second octets 8 plus 8 16 are occupied. That means only the rest 2 can be given. That means 256 into 256. The IP addresses that can be formed on this are 65,000 IP addresses. Okay, this is what CIDR range is. So if you build a very big network and if you chop it into pieces so that you can apply the policies and rules for each and every subnet of your choice. So rather than you build one big network and rather apply policies just to one big network, rather we create big network and chop that into pieces or break that into multiple networks. We call them as subnets and we apply policies on the top of it. Okay, so that's where subnets are going to be helpful. Any questions on this, anyone? Any questions? Questions? Any questions, anyone? Okay, all right. Okay. Now, what I wish to do is, okay, so here is how I want to do. So by default, you might think, Manoj, but you're saying that we need to have a network if you want to use any network or any computing device, any server. But in our AWS account, we have not created any public IP address, any network. But how did we happen to create the servers all these days? Interesting. That's a good question. By default, AWS, in each and every region you select, okay, there is a service called as a VPC. VPC stands for Virtual Private Cloud. This is a service that is offered on AWS to create, build, and manage your own network. So by default, in each and every network or each and every region that you select, there is a region. Okay, there is a VPC, which is a default VPC that is created by default. And that's the reason we are using this. Okay, so here, if you see this, what is the size of the network? And the CIDR says /16. That means /16 means first 16 bits, 8 plus 8 bits are occupied. That means last 2 bits are empty. So that means octet. Okay, so one octet is offering, okay, one octet is offering 256 into 256, so 65,536 IP addresses. So what if I want to big some bigger network, I can reduce this number. AWS offers a big network of as much as possible as /8. Okay, so you cannot go beyond this. What is the biggest? Okay, I think /8 only, you cannot go beyond that. Yeah. So the largest, okay, the support, okay, in IPv4, let's try to be very clear, because AWS even started supporting IPv6, which is the next version of IP addresses. So the largest IPv6 supported in AWS VPC is this. The smallest IP is this. Oh, you cannot go beyond it. Okay, all right. So let me try to create a, so you cannot go beyond this. And if you want to go bigger network than 65,000, Azure supports it as far as I know. Okay, the small, okay, the largest IPv4 support in AWS is this. Okay, and what is Azure? I think Azure supports still /8. I don't think anyone needs that much bigger network. Okay, so the largest supported, I told you, right, /2. It's very big network. It supports even 4 lakh. What is CIDR calculator? Okay, if you say 10.0.0.0/2, okay. If you see this, it almost offers unit tens, hundreds, thousand, 10,000 lakhs, 10 lakhs, crores, 10 crores. So 107 crores, 37 lakhs. It's a very big network that it can follow. I have not seen anyone using that much big networks as far as in my experience. Okay, the largest you would see anywhere is 15 or 16. That's it. Okay, because I don't see anyone would need these many IP addresses, because the size of the network increases, the complexity around also increases. Okay, and also the reason why Azure started supporting is mostly Azure is used by bigger companies, very big companies. Okay, in the case of AWS, it targets both bigger and smaller companies, but again, you don't see any big network, and no one creates such a big network in Chrome. Okay, this is a very important question. In interview, if they ask you what is the biggest network that you can provision in AWS, it is /16. And the name of the service in AWS that offers network as a service is VPC. VPC is a regional service. Okay, that means if you create a network in North Virginia and if you attempt to create a resource in Frankfurt, you cannot, because VPC is a regional resource. All right. Any questions on this? Okay, all right. I don't think any questions. Now with this, what I would like to do is, okay, to expand our footprint. Okay, so what I would like to do is, here is how I would like to do. Okay, because I want to make sure we are pretty much solid with what we talk. in the interest of networking. So what I would like to do is, again, keep in mind, by default, devices in one network cannot talk to other network. Okay. So yeah, so what I would like to do is, this is my default VPC. I would like to build a expense VPC. Okay, what I would like to do is, I would like to build a expense VPC, and I would like to build a network of with just 256 IP addresses are enough as per my business. So what I would like to do is, I'll just go with 172, because private IP address can be 10 series or 172 series. Okay, 170.16.0.0/24. When I say 24, first three octets, 8 plus 8 plus 8 are completed. That means you would get maximum of 256 IP addresses. Okay. So how do I know? So let's go here. Let's ask 172.16.0.0/24. Okay, it offers 256. And also, the very important thing to be considered when you're building the network is, if you are having multiple networks in multiple regions, or if in your organization, if you're having multiple AWS accounts, okay, multiple AWS accounts, in that case, you need to make sure the network that you use should not collide with the existing network. So if I use 170.31, and here, if I see I'm saying 170.16, there will be a chance of collision. So it's better to go with 10 series. Okay, so that there is no collision. Okay, again, 170.16 and 170.31, they're not colliding, but make sure the network that you are using versus the networks that are existing should not overlap with each other. Okay, that is a key point that I would like to mention. Now, what I would like to do is, this is a very big network, right? 256. What I intend to do is, I would like to create two small networks. Remember this? Okay, this is subnet. Okay, and I want to make this public. So when I say public subnet, machines that are launched in this have public IP address, and at the same time, they can be accessed from the internet. Okay, when I say public network, let's talk about it. Public subnet. Okay. Okay. And subnet. Okay, so for example, whenever you launch any instance, okay, so this is a VPC that is available, and if you want to see what are the subnets that are underneath this, okay, so it has created 5 subnets. So each and every one is 170.31, 170.32, 170.31.80, 31.160, and it is offering /20. And if you see, each and every subnet is created in a specific zone, and each and every subnet that is created is offering 4091 IP address, 4090 IP addresses close to, which is very decent network. Now, what I want to do is, if you attempt to create any instance, okay, if you attempt to launch any instance, okay, so you need to select, okay, you're not selecting the network, Okay, you're not selecting any network because it is by default it is selecting. If you have more than one subnet, it gives you the option. And if you also see there is no subnet preference, I'm giving subnet 5. By default, it is giving you the public IP address. Okay, since it is a public subnet, you are getting IP by default. Okay, if you choose the subnet as a private, you won't get this option by default. Okay, that is one point I want to make it clear. Next is this is public subnet, right? Private subnet. A subnet that cannot be, that is not accessible from the internet. Okay, a subnet that offers only private IP address when we launch any devices on it by default. Okay, devices. Okay, you cannot connect to the devices. Okay, subnet offers. Okay, this means devices created on this network cannot be accessed from the internet, but has the capability Any questions, anyone? Am I audible?
Yes, Manoj.
Okay, all right. So are we clear so far what's being covered and all?
Yeah, yeah, it's clear.
Okay. All right. No, devices that are created on this cannot be accessed from the internet, just like how we are doing. But if the machine wants to talk to the internet, for example, okay, so if someone asks you without public IP address, can the machine talk to the internet or not? The answer is yes. Okay, there are some devices through that mechanism. So we are going to build a mechanism through which you cannot access the machine from the internet, but others can access it. Okay, from them if the machine wants to talk. So and then we'll create two instances, and this is public subnet and this is private subnet. Okay, guys, try to listen carefully. I'm putting a lot of effort to teach this concept. Okay, I can directly hit the other topic, but this is important. Okay, now I'll also launch instance here, my front-end machine. This is my payment server. And this payment server cannot be accessed from the internet, but this front-end server can be accessed from the internet. Okay, how do you do that? Okay. Okay, so let's call it as okay, one is public subnet 001 and there is private subnet 002. And when we launch an instance here, it should offer a public IP address. When you launch an instance here, it should offer a it should not offer a public IP address. Now, this is a bigger network, right? 0000024. Now I want to break this into two pieces. Okay, it's if you assume it's just like a bigger network. Okay, if you assume this as a bigger network, rather than managing it in a single shot, what we can do is we can break that into two pieces. Okay, like subnet 1 and subnet 2. Okay, though it is a single network, but we administer it into multiple pieces. Okay, so how can we do that? Okay, so David C. Now, what is the CIDR range that we 10, 10, 0, 10, 10, 24, right? Okay, now it's offering 256. Now I'll divide it. Okay, the moment you divide it, these values will change. Okay, now if you break that into two pieces, the first network range is 10, 10, 0, 0, 25 slash 25. That is subnet 1 that offers 126 IP addresses per subnet, and the other is 128. Not this one. So slash 25. Okay. Done. This is a CIDR. And the other one is this slash 25. Okay, so this is what it is. Okay, now first step is create a subnet. Let's go ahead and this one. Network.md. Steps to create network. First thing, create VPC with the name and range of your choice. Once you make a choice, once we decide the CIDR or network range, you cannot upsize or downsize it. Okay, so this is a very important point. Now next step is decide the okay, this concept is called a subnetting. Let's do it. Okay, now I will be going to VPC, which is nothing but virtual private cloud. Okay, now VPC. Now we already have one VPC. I'll create another VPC, and this time I'll name it as expense VPC. Again, there are a lot of other options which you can mention. I just want one subnet here, one subnet here. It provisions everything, but you will not learn anything. Okay, so let's go creation in the manual mode. Okay, expense VPC. Again, you don't have to say VPC as a VPC. Okay, now it even offers IPv6 as well. So IPAM allocated. Okay, so we do not have any IPv4 IPAM pool, but let's talk about it. So this is a very latest and brand new concept. So let's go with this IPv4 manual input. Now, what is the range that we have selected? 10, 10, 0, 0, 24. Okay, now IPv6 block. So though you are supplying IPv6, do you want IPv6 IPv6 addresses that are owned by me? I don't want to use IPv6. IPv6 is not supported by most of the applications. Okay, but let's not go there. So how an IPv6 looks like, how an IPv4 versus v6 looks. Here is how it looks like. Okay, if it is a 32-bit IP address, this is how it looks like. If it is an IPv6, this is how it looks like. If you see your cell phone, once you connect to your Wi-Fi, or once you turn on the mobile data, and if you see what is my IP, you'll see something like this. Manoj, you said IP address will be looking like this, but I can see in my network and my application of my mobile, I can see the IP address as this. Okay, this is IPv6, which is the latest, but all the server-based applications and all the applications, you would be seeing them using IPv6 only. IPv4 only. So let's stick to IPv4. All right. You already created the VPC. And this is another concept, tenancy. So tenancy default or dedicated, when you choose it as a dedicated, okay, the devices, everything that are used are dedicated, and at the same time, you cannot create, okay, shared instances. Okay, so you can run instances in your VPC on a single tenant dedicated hardware. Select dedicated to ensure that this launched in this VPC uses the tenancy attributes. Okay, but select dedicated to ensure that the instances you can run are on dedicated instances regardless of the tenancy attributes specified at the launch. Okay, what is this means is, if you create an instance hardware, by default the tenancy is shared. That means this device, this AWS owned hardware. Okay, you can launch an instance, okay, and you can launch instance, let's say payment, okay, and other company can also launch their own instances. Okay, let's say there other company instances can also run on your hardware. Okay, this is called as a default shared tenancy. Okay, but a lot of companies, what they do is they go with a dedicated tenancy. What does it mean? So if you go with the dedicated tenancy, okay, if you go with the dedicated tenancy, so AWS offers you an instance, okay, where only the instances that belong to your account will be launched. You don't see any other instances. Okay, but even if you launch one or two instances, but if rest of the instance resources are left out, right, so you have to pay more billing. But the reason, there are some companies which go through the compliance, they feel that running applications on a and shared hardware, there are chances that someone can steal your data. As per the company policy, we go with a dedicated tenancy. So in that case, all the instances that you share, and the C workloads that you see are running on the host, where other workloads of your same account would be running, not other accounts. Okay, but what this means is, so when you intend to do that, if you select this as dedicated, what are the instances that you launch, by default they are going to be are on the dedicated, so which is going to be very costly. Let's don't do that. Okay. Okay, that's it. You create a VPC and the size of the network is this. Done. Once you create the VPC, you need to create a, what is the next step? As per this, you created the VPC. Okay, let me delete these two. You created this VPC. The next is this. Let's do it. Okay, any questions, anyone so far? Any questions? Okay, all right, I'll take it as no. Now, next step is to create the subnets, and these are the ranges of the subnet: public subnet 001 and private subnet 001. All right. Now, so the subnet should be created underneath the expense subnet, right? So we can also add the project name. Okay. I would like to create the subnets underneath this, and the name is expense public. Okay, and I want this to be created in East 1A. This you can select. I want public subnet to be in East 1A. Done. And what is the range of this? So what is this? Is what we decided, right? The public subnet should be this. Okay, done. And they're offering some sizes, if you see, upsize and downsize it. You really don't even have to go to David C calculator and do all this. Next, that's it. You created the public subnet. And next, okay, you have another option. Okay, this time I would like to create an East 1B, and the range of this is this. Okay, now this one is private subnet, but where can I mention that this subnet is public or private? Where do I get these options? Okay, once you create the option, okay, so you select this, there is an option, edit subnet settings. There is an option called as enable auto assign of public IP address. Okay, this is not disabled, this is not enabled by default. Earlier this option was enabled by default, but right now they, as I tell you, in real time 99.99% of the times you don't see public IP address. Okay, because we don't expose any application directly to the internet. Okay, so if you want to have IP address here, you can assign it. Okay, so since it is private IP subnet, I don't want it, but for the public subnet I would like to enable it, so that whenever you launch the instances, by default the setting is it enables the IP address. Okay, that's one thing I would like to do. Okay, that's the difference. So when you launch any instance, let's see. Okay. Now I launch one instance. Let's go here. AMRs. Launch an instance from the AMR. This time I'll call it as a public server. Expense public. Okay, DevOps lab major line. Okay, and the username is EC2-user. Done. And this time I would like to go with the T2 micro, and at the same time proceed without a key pair. And here I'll choose the network. Okay, so I'll choose VPC expense, and this time I'll choose public subnet. Okay, see here, by default AutoSN is disabled, and if you go to the public subnet, by default it is enabled, though you can disable it. Okay, by default it is enabling it. Now you also need to create a security group. You might think I have already the security group, why it is not allowing? Security group scope is also VPC. That means you create the security groups on the top of VPC. That means if you have two VPCs, you cannot use one security group in one VPC to other VPC. Okay, I'll say you don't see anything. That's the reason. Okay, I'll select a security group, expense public SG. Okay, now from here I'll select this and I'll allow element from the network. That's it. I'll launch the instance. Okay, now you did front end expense instance, which is public, that will be having the public IP address as well. Let it come up. Now you can see it has offered both public and private. Now the other instance, okay, expense payment, which is a private server. Now here, this time I would like to proceed without a keeper, but here I would like to choose the expense network, and I would like to choose the private subnet here. Now the moment you select the private, this option is disabled by default. Now I'll be selecting, okay, an existing security group, create a security group. So what I'm going to do is expense, I'll follow the standard naming, expense private SG. Okay, and I want to make sure this can only be accessible by this. Okay, only this particular payment machine can be accessed from this particular network, not anyone else. Okay, I'll just say 10 10 100 024. Okay, so here what I'm going to do is SSH is accessible only from custom 10.10.0.0.24. That means only people who are within this network can talk. Okay, not the outsiders. Okay, all these days we are using graceful network of 0000, but this time no. Okay, let's launch the instance. Now this time the instance that will be launched won't be having the private IP address. Okay, would be having the public IP address. Okay, it will only be having the private IP address. And expense front end, you see both public and private. But if you see this expense payment, it's not having the private IP address. Okay, clear? Any questions on this? Anyone? Okay, all right. Now, let's try to connect to this instance. And we know when we try to connect to this instance, you cannot because you don't even have a public IP address. Now, how many of you say when I try to SSH to this, I will be able to? Anyone? Can anyone say? How many of you say it will work? Dolly, Mridula, Shailaja, Ambit, Arun, Mahendra. Anyone? How many of you think that we can access it?
This one we can access, I think, but not the private one.
Sorry?
This one we can access 54 address, public
Okay,
address.
all right. The answer is no, we cannot. Okay. So, for example, if you want to have access to the internet at home, what is the thing that you do? First thing, if you want to have access to the internet, what is the first thing that you do at your home? Anyone? You dial into the local internet service provider like Geo, Act, or a local internet provider like Excel. You talk to them and ask them to have an internet connection, right? So what these guys do, they they form the cable and they try to add a device called as a router, correct? Agree or not? So that router is a device. Okay, what is a router? Let's talk. A router is a device that helps in connecting two networks. Two different networks. Your home network is a default network and the public network is a different network. So you need to have a router, right? And once you have the router, that means you are connected to the internet. Okay, you are connected to the internet. Now router, when they offer a public IP address to it. Okay, that's the reason. Okay, that's the reason. Okay, in your home, Okay, you might be connected to 10 devices. Your TV will be connected, your cell phone will be connected, your iPad will be connected, your all the Internet of Thing devices will be connected to the same network. And that's the reason you are not being offered each and every device that is connected to your home won't be having individual public IP. Okay, your home identity is your router's public IP. And all of you, rather than just giving you the public IP, this router will offer you a private IP. Got it? So that means even though you have 100 devices at your home that are connected to a single IP, it doesn't mean that all the 100 devices to connect to the internet will get 100 public IP addresses. Rather, this router forms a private network. Okay, this router forms a private network. Okay, which assigns private IP addresses to it, and all of you guys will be connected to this. Okay, so here in the AWS terminology, we call it as IGW, stands for Internet Gateway. Okay, a gateway or an exit and entry point to access the internet. Okay, that's what it is. Okay, let's talk about Internet Gateway. So, hey, you have not created it. Okay, because by default, AWS offers a public network that already has an internet gateway. Yes, okay. Now I'll name it as expense. It's always recommended if you're dealing with 2 to 3 projects in a single account, naming standard is very much important. Okay. So I'll create an internet gateway. Once you create an internet gateway, you also need to attach it. And that's the reason it is prompting you, hey boss, you have created an internet gateway. Would you mind attaching it to VPC? Yes, I intend to. So available VPCs, whom you want to allocate it. Keep in mind, you can attach one internet gateway per VPC. That means one gateway can be a part of one VPC. Okay, so you cannot have more than one internet gateway to a single VPC. That also means one VPC cannot have more than a single gateway, internet gateway. So I just attach it to the internet gateway. That means I created a gateway router and attach it. Okay, so user computer. So from my home network, okay, now here, if I attempt to connect, okay, now since there is an internet gateway, let's see whether we can access it or not. Let's do it one more time. And if you see this operation timeout means you are attempting to connect, but it is not reaching. Okay, so timeout versus refused, we already discussed. If you see the timeout exception, that means there is a firewall exception. That means someone has not opened you. Refuse it, that means the connection has bypassed the network and reached the server, but a device is denying the request. Okay, not at the network level, but at the application level. Even now, you cannot connect. Okay, let's wait. Now you can get the operation. Mm. And you cannot, you will still see the timeout exception. So here, from here over the internet, your request is reaching the public gateway. But how does, okay, your this subnet comes to know it has to accept the request from this particular gateway? How does it come to know? Okay, so how does it come to know? Okay, so this can be done by using something called as a route table. Okay, so there is no route from internet gateway to this public subnet, so that's the reason you need to create a route table. Okay, create internet gateway. You see? Next, create route table for public subnet with a route saying okay, that means you're telling you're telling the requests that are coming from IGW has to be routed to me. Okay, create a route table. I'll just say again, naming standard is very much important. Just by looking at the resource, you should understand which project it belongs to, which environment it belongs to. Okay, expense public RT, public route table, and I would like this to be created on this particular VPC. That means the route table scope is also within the VPC. Okay, now you have created the route table, and then this route table you created, but you also need to associate it, right? So what you did was you just created a route table. Okay. Okay, and you define the route. Now you need to attach this to the subnet, right? So how can you do that? So you need to associate it. Okay, you need to attach it, and that's where subnet associations are coming. So carefully remember all this, okay, because we do the same thing when you deal it with Terraform. Okay, now I want this public route table should be attached to the public subnet. Done. Now you also need to define the route. Okay, saying that if the requests that are route propagation, so you have the route, yeah. Now there is a route that is already in place. That means if anyone who wants to talk to this particular destination, use the local. That means local is a switch. Now I'd like to edit the route and add the route. Okay, that means destination, if anyone wants to talk to the internet, okay, all they have to use is internet gateway. That means you're telling requests that are coming from internet gateway can be addressed. Okay, expense IGW, save it. Okay, now it has a route. Okay, now let's also add the documentation. Done. Now let's try to SSH again. You got this timeout exception, right? So I keep on saying operation timeout or connection timeout. That means firewall is blocking or there is no path to it. Okay, and connection refused means the request whom you are trying to reach is reached, but it is denying the request. Okay. Now this time you should be able to connect. Okay, and this machine will also be having, let's try to make it as sudo set hyphen host name front end. Okay, sudo ping google.com, you get the response. That means this machine has access to the internet. Now from here you should be able to talk to the private instance. Okay, keep in mind 99% of the times you don't see any of the machines having public IP address in the corporate. Now if you want to connect, okay, as mentioned in the picture, if you wish to connect to this instance, okay, I'm repeating, if you want to connect to this particular instance, okay, this payment can only be accessed from the particular range. Okay, 10 series network. If you try to connect SSH to this, you are connected. Okay, so set hyphen host name, and you can all clearly see it is 10.10.0.51, and it's 10.10.0.51, right? And it's 10.0.0.214. This is subnet 1 and subnet 2. Okay, which is a private server. Okay, now since it is private, okay, you can see there is no public IP address associated. And if you try to ping to google.com, how many of you say will it have access to the internet or not? Anyone? 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 Anyone?
No, sir.
Anyone? Okay, one answer no. Anyone else?
It's not accessible.
Sorry?
It's not accessible.
Okay. All right. If I try, okay, let's see. So that means this machine is not having access to the internet. So is it good or bad? See, the rule of thumb is I don't want people from internet should be able to access to this machine directly. That I already achieved. But how about if this machine wants to talk to the internet? For example, if you want to install a package, or if you want to update your system, how does it work? Okay, if you say sudo yum update -y, it will never work because it doesn't have access to the internet. We clearly mentioned anything works if you only connect to the internet, correct? So that's when, okay, we use a NAT gateway. Okay, create a NAT gateway and attach it to the public subnet in the route table. Add the route 0.0.0.0/0. Use NAT gateway. Okay, so the next thing that we have to do is we need to create a NAT gateway. Okay, NAT gateway, if you are using it for the purpose of enabling communication, you need to use a NAT gateway in the public subnet. And here, while you're creating the private route table, you need to add the route. Okay, now public route table and private route table. So here, okay, any questions, anyone so far? Let's take a pause. Okay, that's when all this comes up. Okay, so let's try to create a NAT gateway and mention the route here. If you want to talk to the internet, use NGW. Again, NGWs are of two types, public and private. So if you so public NAT gateway is used to enable private to the public communication, but private NAT gateway is used, for example, if you're having another subnet. Let's say you're having another subnet. Okay, and here if you're having hundreds of machines, okay, and if you want to prevent people knowing what is the actual IP address of this, what you can do is you're going to create a private NAT gateway, and all the devices that are talking from here to here would be thinking the source IP address as the NAT gateway. Okay, this is just to make sure mask the private IP address of the actual instance as well. Okay, but I'm not interested in talking that, but just explore that. Okay. Okay. Now, again, NAT gateway is a paid component, by the way. Okay, you don't get it in the free tier, so make sure you delete it. NAT gateway and internet gateway offers you it checks out an elastic IP address. Okay, so expense in GW naming standard is very important. So where do I need to attach this public expense NAT gateway, in the public subnet or private subnet? Anyone? Just by looking at this diagram, what do you think? Okay. All right. Mm, 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 mm. Okay, now it has to be created in the public subnet, as I mentioned. So it's a public subnet. I have to be creating this in the public subnet. And again, you want the connectivity to be public or private. You can even select the private. So private NAT gateway cannot reach to the internet, as I mentioned. This is only for masking the source IP address of the machines that are communication between to private or public subnets. Okay, so elastic IP address is needed, which is nothing but a public IP address is needed because it enables the public connectivity. That's it. Now done. Now the next thing is, okay, as per the architecture, you need to have a route table. Okay, so go here and create a route table. Expense private RT. Expense. And you need to associate this to the private subnet. Okay. Once it's done, you need to add a route. The route is if you want to talk to the internet, then use the NAT gateway, and the NAT gateway that I have is expense NAT gateway. Okay, and again, the moment you provision this, it will not work immediately because it takes some time. Okay, you have successfully created a route. Okay, so yeah, now try to ping google.com. Earlier you didn't get response. After some time it will work. Okay, so this way you can enable communication from public to private and private to public. Clear? Any questions on this? Any questions on this, anyone? It takes some time. Okay, don't worry on it. It takes really some time. Any questions on this, anyone? Can you see this? Communication is enabled. See this, there is no IP address, public IP address to it, but still it can connect. You can also sudo yum update nginx-y. It can even talk to the internet. That means though this machine don't have an IP address, though this cannot be accessible by someone from the internet, but if this machine wants to talk to the internet, it can go and talk, okay, through the help of NAT gateway. All right. There is also another concept called as VPC peering. Okay, what if you have another subnet here? Okay, in our case, we have another subnet, right? Default VPC. Maybe if you guys permit, I'll complete this as well. How many of you are okay if I spend 5 more minutes of time? Just 5 more minutes. You guys are okay if I spend 5 more minutes of time?
Yes,
Shailaja?
Manoj. Yeah,
Okay.
yes.
All right. So here, if my workstation wants to talk, okay, so here, what is my VPC? My default VPC is this. Okay, 172.31 network. Okay, yeah, it went and talked to the internet. Okay. 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 Now take this. Now what I want to do is, see here you need to be very careful. If you wish to talk, Okay, now what I want to do is I want my workstation to be started. Let me start my workstation. Let me start my workstation. And my workstation IP address is 170.31. Okay, now if this machine uses a public IP address, the communication will be like this. Okay, let me put it very clear. Even this will have a router, right? If you use a public IP address, okay, if you want to talk to this front end using the public IP address, the communication will be like this. That means the request will go over the internet. Then it has a lot of hops in between. Okay. Okay, from here it talks to this. Okay, so here in between lot of hops are available. Okay, but if you use private IP, it will not work. Let me try to show you that as well. Okay, come here. Let me try to connect to my instance. Okay, now here, this is in the 170.31 network, right? Okay, if you look at this, this is in the 170.31 network, and this is in the 10 series network. And if you exit from here, okay, they are in the 10 series network. Now from here, if you attempt to connect to this instance, okay, which is in a different subnet, using this, obviously it will work. Okay, the reason why it will work is because you're using public IP address. Okay, when you wish to use the public IP address, it goes over the internet. Okay, that means which is not a great way, and in between there are a lot of hops and there will be a lot of latency. So it's always recommended if you're having more than one subnet or if you're having two AWS accounts, okay, you don't communicate using the public IP address. But if you wish to connect using the private IP address, obviously it will not work. Okay, because by default one network cannot talk to the other network. Okay, for that, to enable that, you need to trunk the network. Okay, the concept is trunking, but technically in AWS terminology we call it as a peering, AWS VPC peering. Okay, let's stick to that terminology. Okay, this concept is called as a peering. So let's try to do it. So let me show you, it will not work. Okay, so what I can do is VPC peering. This is a concept that helps you to enable communication between two VPCs, and these two VPCs, this enables communication okay, both the subnets can be in the same account or a different account or a different region. Okay, even AWS has evolved. Earlier, you need to have both the accounts in the same, you need to have both the VPCs in the same account, you need to have both the VPCs in the same region, but down the line, they evolved. Okay, I would like to create a VPC peering. So I'll create a peering connection. So default to expense peering. Okay. Now from where you want to initiate this, select a local VPC to pair with. I'll say this VPC. Now, what is the other VPC that you are going to talk? If the VPC is in another account, you need to mention the account ID like this. Okay, but in my case, and that too, you also need to mention in which region it is in the destination account, and that guy has to accept it. Okay, it's not just like I want to talk to this guy account, I know his account ID, I'll just directly enable communication. No, 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 no. Okay, that guy also need to accept it. Okay, but in my case, both the accounts are in the same region and the same account. Okay, so I'll also mention the destination is expense. Okay, so that's the reason I was telling you. So to do the VPC peering, the source and the destination VPC CIDR should be different. If they are same, you cannot do the peering. Then you need to resolve that. Okay, so create the VPC peering connection. Okay, now once you created the VPC peering connection, okay, now go here and try to check the status. Okay, this has to be accepted. Okay, just like how since my source and destination on VPCs are in the same account, I got an option to accept this or deny it. Okay, if you get a request from a different account, okay, you'll get all the options, who has initiated it, who is the owner of this, all these things. Okay, based on this, you'll approve it or deny it. I'll approve it. All right. Now in the route table of the default, so here now in the expense public route table, I need to add a route. What is what I need to say? I need to go, if anyone who comes from this particular network, which is this 172.31 network, they can be allowed. So let me try to do it. So peering, if anyone is coming from this particular network, so use the peering connection. What is the peering that is available? This one. Perfect. Okay, likewise, you also need to do it for private. Done. Okay, done. The next thing is, now here you told to this and this, okay, if anyone wants to come and talk to me, they can use. That means this guy can talk. Likewise, if these machines wants to talk to this, even this guy will also have a route table, right? You also need to add it. So how do I come to know my workstation route table? Go to the networking and you can see subnet, and you can see the subnet route table here. Select this, read the subnet route table association, and you need to add a route. How to add a route? Route table. This is the route table. Select this route table ID. Edit the routes. If someone who is coming from this particular network, allow them. 10.10.00.24. Okay. You can use this pair. Okay. That means we are telling, okay, if someone is coming from this particular network using this peering connection, they are accepted. That's it. Okay, now since you have created this peering, now you come here. Earlier it didn't work, right? Now 172 series to 10 series to, from 172 10 series it didn't work, right? Now if you try to attempt, it will work or not. Let's see. Okay, another reason. And go and define this 172.31 network as well. So here in the instances, Consider it as default VPC. Takes some time, but it will work. Okay. So likewise, in the security group also you need to do it. You can see if anyone who attempts to connect from this is also allowed. All right. Now it takes some time and then it will work. Okay, because the peering has to go through. Default pair is appearing. Take some time and it will work. I'm quite sure on it. So these are the route tables that are associated. And if someone asks you, how do you come to know what all subnets are associated with the peering that you have connected, you can do it. Now, but here there is a VPC route table. There are no subnets to it. Interesting. Yeah, all of them are. No worries. Then why it didn't work?
Manoj, I think in the workstation route table you have given the 10.0.0.0, right?
Is it?
Instead of 10.10.00.
In my workstation? Let me go and
Yes.
check. Thanks for that. You're right. So from here, if you have to connect to this also, it should work. If it doesn't work, it takes some time to operate, okay? But it will work. Okay, I'll leave these as is. I'll just turn off the instances. I'll leave these as is. We'll bring them tomorrow. They will work. Okay, that's all. That's for today. If you have any questions, you can ask. If not, we are good for today. And again, thanks for staying more time today. I really appreciate that. Any questions, anyone? Okay, I'll take it as no. We'll see you tomorrow in the session. Thank you. Any questions, anyone? All right. Thank you. Signing off. Bye.